So I'm going to let you handle questions 10 and 11 on your own. And I think I mentioned before that you will have questions at the bottom of this week in your homework that will ask you, so you don't have to turn this paper in, you will be asked these questions in a quiz separately. Okay, so for question 12 it says click in cell E2, which two cells are we dividing? We're trying to find the per capita GDP or GDP per capita. So we are going to take the GDP amount and then divide by the population, a number, and I need to be sure to scroll to the top to do this. So click in cell E2 and then just type equals B2 divided by D2. And these are raw numbers. The GDPs are dollars and these are people. So dollars per person is what we're generating. Unlike here where we also had to multiply by a million, we don't have to here. So B2 over D2, and then fill down the division formula, and so hover here and click again. Click, release, hover until you get the black plus, pull down. I think my computer did something funny. Try again. Hover, click, and pull. Nope. Click and pull down. And keep going. Click and pull. I don't know why I'm going to the dictionary by accident. This is easier with a mouse. Go to the very end. By the way, I believe there are just under 200 countries in the whole world, so that's why this spreadsheet is super long. Okay, Eritrea, I used to know someone from there. Little country right by Ethiopia. CO2, 0.2 tons per person. GDP per capita, 2321. These are some African countries that tend to be kind of poorer, many of them. Let's scroll up to the top. Where are the richest countries? Which 5 countries have the highest per capita GDP? So we want to sort this table. Well, we want to sort the entire spreadsheet by these values. So you're good at this by now. GDP per capita, Z to A. All right, so once again, Luxembourg, Macau, Switzerland, Ireland, and Norway are at the top. So that would be the answer for that. Luxembourg's per capita GDP is almost 120,000. US is 67,000. So Luxembourg's GDP is about blank times the US per capita GDP. You're comparing with division. And then you can do this again between the US and China. Relationship between per capita emissions and per capita GDP. Is there a relationship between these two? Do you think that richer countries have higher emissions? That's what we're going to investigate. And we're not just going to get mad at the big countries because we've divided by the number of people. That's what per capita does. So we're going to make a graph with the data in columns E and F. So I don't want to have the whole chart selected. I just want to select these 2 columns. So again, I click in the center, hold, click in the center, and then drag over and select E and F. And then go to Insert Chart. So Insert Chart. And a scatter plot should appear. Think about what the graph is communicating. I don't want that map. Okay, what is this graph communicating? So we have sort of a mess of dots here. We have a lot of dots right in this corner, which means poorer countries, low GDP, low CO2 emissions. There's a cluster. And then it kind of spreads out. I'm going to show you how to change this a little bit, but we do see that there is a little bit of an upward trend. So that does confirm that thought of richer, higher emissions. But there are some richer countries that don't have very high emissions. They tend to stay a little bit the same. So it's not a perfect relationship. Where do you think the US is on this graph? Well, if we go back to our data, let's move this for a moment. The US has 67,000 for our GDP per capita and 15.5. So 67,000 would put us about here. That's not us. We're a little higher. Here we are. That's our dot. 67,000 and 15.5. So now we're going to edit the axes and change the way the axes are scaled. Right now they're scaled by 25,000 here and 10, 20, 30 here. If we go to Edit Chart, we're going to go to Customize, Horizontal Axis, and change this to Log Scale. Then go down to Vertical Axis and change it to Log Scale. And it really changes what this graph looks like. All of a sudden, there's a very strong linear relationship between these two data. And notice that this is no longer equally spaced. We have 5,000, 1,000, sorry, 500, 1,000, 5,000, 10,000, 50,000, 100,000. This is called the logarithmic scale. And it's a little strange, but it's something that's commonly done, and you'll see this in Mr. Rosling's books. These are no longer equally spaced. They're actually doubling at regular intervals. And that's what this is showing. 0.5 doubles to 1, 5 doubles to 10. So now the graph looks like this. As GDP per capita increases, what is also increasing? It's the CO2 per capita. So as you get richer, you have higher CO2 emissions. And that is what the Uruguay article was talking about. The graph below is an example of a data visualization. The graph is similar to the one you made. What additional information is visible here that isn't in the graph you made? What's the difference between this graph and this graph? Well, the cool thing here is that the population of each country, the big countries get a bigger circle and little countries get smaller circles. Whereas here all our dots are exactly the same. So this graph is a little bit better, and this comes from the Our World in Data website that you looked at last week for your journal. And I have a link to that graph here, and you can certainly hover and explore. Oh, there's Bolivia. And see different countries. And notice that even here you have the option to switch this back to linear on both. And that gets us back to that weird graph that we started with. And then you switch these x and y to logarithms and you get that nicer graph. One more thing is that you can go here to a different website and visit basically the same graph. GDP per capita. This is not CO2. Oh, it is per capita. It's tons per person. So this graph is the same graph again. This is showing it with 2017 data. Does that look the same as this? More or less. The US is in the upper right corner. Here's the US. And the crazy thing about this website is that you can actually press play. And what you're seeing is how this relationship changed over time. And that's what Rosling was talking about in our article this week, is how things have not stayed the same. In the 60s, they were one way, and all these countries are making progress and coming out of poverty. And as they come out of poverty, they increase their CO2 emissions. I also wanted to show you that you can click on a country. So let's choose Bolivia. And Bolivia is in South America, so that's why it's colored as a green dot. And then you can press play and watch Bolivia changing over time. I'm going to just pause right there. Did you notice that Bolivia was going forward and then it started going backwards again? So I don't know what was happening, but I was born in Bolivia right around here. And I think there was political instability, so that might have created this return where GDP started going backwards. And then it starts going forwards again. And now CO2 emissions are also rising. And I'm not sure why Bolivia drops off there, because it looks like the data stops. Oh no, that's where we are in 2017. Okay. So they're still well below the global average in terms of their CO2 emissions. And this is saying 1.96 is their tons per person. Let's see what we had in here for Bolivia. I'm going to do a Control F, Bolivia, and we have CO2 at 1.8 and GDP per capita 4,000. So clicking here, 1.8, okay, not that different. And this is saying 3290. So slightly different values, but not too far off from the data that I had dug up. So again, I'm not using the exact same data they have, but with my digging, I was able to come up with these figures, and they're pretty similar. Anyway, you can change the graphs that you explore here, and you could, instead of having GDP per capita, you could explore, oh, here's what we should do. Babies per woman. Babies per woman and GDP per capita. And here's Bolivia. And look at that fast downward change. Oh, babies per woman coming down the entire time. So this is that period where Bolivia was losing wealth, but babies per woman was still coming down over this time period. And if we uncheck Bolivia, we can then just look at the whole world. And again, we can watch how did babies per woman change over time as countries got richer. And generally, countries are getting richer as time goes by.